Another way that we can find the Boolean expression that's generating the output column on a truth table is a Karnaugh map or a Kmap. So let's take this example that we used in the sum of products. I have an XY, a truth table with X and Y values, and some Boolean expression f of XY that is generating this output column right here. So what I'm going to do is I'm going to look at the min terms. Those are the rows that are generating ones on my truth table, and then I'm going to map them to a Karnaugh map. So I have two Boolean variables, X and Y, and I have 4 rows, which means that there are 4 different ways that those two variables can be joined together. So what I'm going to do is I'm going to draw a Karnaugh map that is going to show me all 4 of those values. So I'm going to start with X and X naught. And then I am going to draw something that might look a little bit like a spreadsheet. Across the top, I'm going to put the value of Y and Y naught. This is going to give me something that looks like a spreadsheet that has 4 different cells representing the 4 representations. This is the cell for XY. This would be XY naught. This is X naught Y, X naught Y naught. And what I'm going to do is I'm going to map these min terms to the appropriate cell on my Karnaugh map. So this is going to be both X and Y are equal to 1, so that means that I have the min term XY. Because X is equal to 1 and Y is equal to 0, this is going to give me the XY naught min term. So I'm going to try to find the cell that represents XY, and if I find it, I'm going to put a 1 in there. And then I'm going to find the cell that represents XY naught. Well, this is the X row right here, and then I'm going to find the cell that contains the Y naught column, and I have mapped my min terms to a Karnaugh map. Now if I just used the sum of products, I would say XY plus XY naught, and that would be the Boolean expression that is generating that output column. From here I would probably want to factor out the X. We know that that equals 1. X times 1 is equal to X, and this is the f of X, the f of XY that is generating the X. On a Karnaugh map, what I'm going to do is I'm going to map those min terms, and then I am going to group the ones together. So I see that I have 2 ones here side by side. So once I have grouped them, the next thing that I am going to do is I'm going to move through the groups trying to find values that do not change. And so if I move horizontally from column to column to column, I see that my Y and my Y value is changing. If I move vertically from row to row, well, it's only on one row, so the value that is not changing is the X. So what I want to do is I want to write down the values that are not changing. And when I do that, I can see that the only value as I move through the group that is not changing is the X. This is going to be the f of XY, the Boolean expression that is generating that output. And I want you to notice that in a much simpler format, I came up with the exact same answer as if I had done the sum of products and then I had simplified. All right, so if the whole point of a Karnaugh map is to map the min terms and then group them together so that we can simplify the Boolean expression, then we should probably talk about the rules for grouping the ones. So just imagine that you are putting a group of ones, covering it with a rectangle. The first rule is that each rectangle has to cover a binary number of squares, binary value. That's 0, 1, 2, 4, 8, 16, 32. Which means that I cannot group 3 ones together and I can't group 6 ones together. It has to be a binary value. The next rule is that the rectangles have to be drawn as large as possible. So I want to group the most number of ones together. If there are 4 of them that are together, I want to group all 4 of them in one group as opposed to 2 separate groups of 2. And we also want to use as few rectangles as possible, which brings us back to the reason why I want to group as many of the ones together as possible, remembering that it has to be a binary value. Now the rectangles are only drawn vertically or horizontally, which means that I can't group ones that are on the diagonal unless they are in a larger group of 4 or 8 or something like that. Rectangles can overlap. That means that I can have a 1 that is included in more than one group. It could even be in 2 or 3 or 4 groups. in order to create the largest groups possible. And the last one we're going to find out is that the rectangles can wrap around the edges of my Karnaugh map. So these are the rules that apply to grouping. Let's see if we can apply those. All right, let's try a Karnaugh map with a truth table that contains 3 variables instead of just 2. So on our sum of products, we had this truth table that was generating this particular output. All right, so when we evaluated it, we see that it actually has 4 minterms. I'm going to need to map each one of those minterms to a Karnaugh map. Well, how am I going to go about doing it? How do I create an Excel spreadsheet when I have 3 variables and not just 2? Let's say, for instance, that I'm going to put the value of x and x naught down along the side. For each value of x, we are going to have a y and a z. So I'm going to group 2 of the 3 variables along one of the axes. And as I move from column to column to column, I can only change one of the 2 variables. So let's say that I want to trip y to y naught. That means that I have to leave z the same. So if I come to the next column, I am going to leave y naught the same, and then I am going to trip z. And then the last one, I am going to leave z naught the same, and I am going to trip y. By the time I'm done with the values across the top, I should have all 4 of the representations of y and z. So then I'm going to finish drawing up my Karnaugh map, and I see that I have the 8 cells inside of here that go along with each one of the 8 rows on my truth table. So let's see if we can map the minterms. This is going to be x, y naught, z. This is going to be x, y naught, z naught. This minterm will be x naught, y, z. And this minterm is going to be x naught, y naught, and z naught. So I'm going to take each one of these 4 minterms and I'm going to map them to my Karnaugh map. So this first one right here, x, y naught, z, well, it's going to be in the x column. So now I'm looking for y naught, z, which is right here. So I'm going to put a 1 there. The next minterm is also on the x row, is just y naught, z naught. So I'm going to stay on the x row, and I'm going to try to find y naught, z naught. And then we're going to move to the x naught row, which is here, and see if we can find y, z, which is this one. And then the last one is also on the x naught row, but it's the y naught, z naught, which is right here. So as I begin to group them together, I'm going to change the color of my grouping. So let's make this first grouping blue. And then I have another group that I'm going to make green. I'm going to group these 2 together, and if you notice, this one is being overlapped by 2 separate groups, which is just fine. And then this one is all the way out here by itself. So I actually have 3 groups. So let's see if we can evaluate the variables that are remaining the same in each one of the individual groups. So if I look at group 1 right here, if I move from column to column to column, the value that is not changing is the y naught. So I'm going to put the y naught down here. I see that the z to z naught is changing, but the y is staying the same. And then if I move vertically through the row, well, I'm staying on the same row, so that's actually going to remain the same. And so I'm going to put the 2 of these together. Now let's look at my green grouping right here. If I move horizontally through the group, I can see the value that is not changing is the y naught, z naught. And then as I move vertically through the group from row to row, I see that the x, x naught, x, x naught. So that is changing, which means I can include it. And then my last and final group is the red group. So as I move horizontally through the group, I can see that the y, z is not changing. So I'll write the y, z. As I move vertically through the rows, well, there's only one single row, so that x naught is not changing, which means now I have simplified my 3 minterms. And so I'm going to do the sum of the products. So we will have y naught x plus y naught z naught plus y z x naught. Karnaugh maps don't always result in the most simplified of the Boolean expressions. Just by mapping it to a Karnaugh map and grouping them together and then seeing the values that are not changing as I move through the groups, I can create a more simplified version than I would if I were to just create the sum of the product with these 4 minterms. If you'll notice, I have 4 minterms, but when I did the Karnaugh map, I already only have 3, which means it's simplified. If I wanted to simplify this even farther by factoring out the y naught, now I end up with a Boolean expression for f of x, y, and z that only has 2 terms instead of the original 4 that my sum of products would have generated for me.